Welcome back. So in the last session, we have explored how to work with functions. We have learned about how to deal with arguments, various kinds of arguments, and also we have learned how to work with return type and all those things. In today's session, let's focus on libraries. First thing, we'll understand what exactly is a library. Then we'll understand how to use a library and how do we work with a library. Okay. So first we'll understand what is a library first. Okay. So a library, before talking about what is a library, let's assume that you're writing a code. Okay, you're writing a module in your for your software or something, like you're working in a company or writing a software, or you're writing your own software. Okay, let us assume you want to use a specific module. I mean, you want to code a specific module. Maybe you want to develop a simple machine learning model, or you want to use a simple machine learning model for your requirement, or you want to use a simple mathematical system in your requirement, something like that. Okay, so you want to use a specific module. So when you want to write a code in programming, when you want to write a code, you have two ways of writing a code. Either you can write everything from scratch, or use a predefined code, right? Use a predefined code. See, when you opt for writing everything from scratch, in some cases it's well and good, because in some cases, based on a requirement, you should write everything from scratch. That's a good thing. But in some cases, predefined code works better. Why? Because let's assume that you want to you want to build a machine learning model, okay, which is already predefined or something like that. Okay, when you want to use a machine learning model, or if you want to write a predefined code, or sorry, if you want to write everything from scratch, the one important problem here is your development time increases drastically, right? So you should write everything from scratch, test it. Obviously, you should test it. You should validate various test cases, and finally, once you are satisfied, you will be using that particular code for your requirement. So here what happens is development time increases, and due to that, ultimately you should wait for longer time, right? So to avoid this problem only, we have an option of using a predefined code. So what happens in predefined code is, instead of you writing a code from scratch and using that particular code from scratch, what you'll do is you'll be using a predefined code developed by some other developer. Maybe some other developer out there has written a code for you, tested for you in various test cases, and now a lot of people are using it and found that it's very good. So when the community is more, and when you found that yes, this is working, obviously you can use a predefined code and you can proceed with your requirement, right? So in many of the cases, we proceed with using a predefined code. We go with predefined code because it will be helping us to reduce the development time. Your you can focus on your requirement rather than focusing on your every code from scratch, right? So when I talk about predefined code, your library come into the picture. So what is a library? Nothing but it's a predefined code in the form of functions and classes. Functions and classes, or functions or classes, sometimes it depends. So it's a predefined code in the form of functions. You know what is a function, right? We have seen a piece of code which can be reusable in a number of times, is nothing but a functions. And classes, we'll discuss about that once we start the object-oriented programming. So when you talk about a library is nothing but functions and classes. It's a predefined code which has functions and classes, and which can be used by a number of developers. Means, let us assume you are a developer right now. You actually thought of like developing your own library. Let us assume that you are developing a library called as Calci. Let's assume. So you'll be writing all the functions related to calculator, like add, subtract, multiplication, something like that, or you'll develop all the functions and release into the market. A lot of other developers, instead of writing the all those kinds of things from scratch, they will be using your functions, your code, like in the form of library, for their respective task. So in the same way, you also, for your respective task, you can use libraries for your own requirement. So library is something but a predefined code, already written code, tested code for your requirement. Okay, so it is in the form of functions and classes, as simple as that. Okay, perfect. So now let's see how to use a library and how to work with various functions in the library. Okay. But before talking about that, basically I should talk about built-in and non-built-in libraries. Basically, when we talk about libraries in Python, or in that case, any other programming also. We have built-in and non-built-in libraries. So as the name says, built-in means these are built-in libraries, means once you download Python, automatically those kinds of libraries will be pre-installed in your system, already present in your system. So you don't have to worry about installing or downloading those kind of libraries. Whereas non-built-in are the libraries which are not built in your system, and you have to install explicitly by using some command or something like that, or you should download those particular libraries. Okay, but let us first talk about built-in library or inbuilt libraries, then we'll focus on non-inbuilt libraries, how to work with non-built-in libraries also, right? So let us focus on built-in. So one of the built-in libraries which I want to show about is time library. There is a library called as time. Basically this particular library will be helping us to work with time-based operations. For example, if you want to calculate the current time, or if you want to calculate the time of your code, or if you want to give some delay in your code, something like that, all kinds of operations can be done by using the time library. But first thing is, how do we use a library first? So in order to use a library, we have to import the library. If you want to import a library, we should use we should use a syntax called as import space library name. So import is a keyword. Import is a keyword to import any library, and the library name is nothing but your name of your library, which is given by the developer who has developed it. Okay. So for example, if I want to use a library called as time, I should say import time. So example, import time. So once you import time, you can use your time library. So let's see how can we use that. So you can just go back to your terminal and just say, yeah, go back to your Jupyter notebook and we'll just say import time. So if I just say import time, you can see here my time library got imported. Now how to use the functions in the library? If you want to use the functions in the library, you should say like this: library name and give a dot, obviously, and you should call your function name or class name. Okay, let's focus on functions right now. Function name right now. Okay, so I can simply say time dot and give a tab. So if I give a tab here, I'll be getting all the available library or all the available functions in this particular library. You can see alt zone, ASCII time, clock, C time, daylight, gym time. So GM time, local time, MK time. You'll be getting a lot of functions in this library. Let us focus on local time right now. Let's see what this local time does. So I'll just say time dot local time. So you say time dot local time, you can see the current time. This is the current time here right now. Year is 2022. Month, day, hour, minutes, seconds, weekday, year day, all these kinds of information you'll be getting this along with the time, date, and everything. You'll be getting everything if I say local time. So obviously it is taking my system time. Okay, so in this way we can use a function. See, I've not written any code right now. I've not written any code to get the date or time, but I'm just calling a function of a library and it is able to give me the information, right? In the same way, there is one more function called as sleep. Okay, why we use sleep means if you want to give some delay to your program, you can use sleep. So how to use sleep in the sense, you can simply say time dot sleep and you can give your number of seconds. See guys, local time was the function without arguments. Means here we are not giving any arguments in this particular function, but here we have to give the arguments, and the argument is nothing but seconds. You know, right? We can use functions with arguments and without arguments depending on our requirement. But in sleep, compulsory you have to give the arguments. If you don't give the arguments, it throws an error saying that sleep take one argument. Okay. But before working with sleep, let me write a simple code. Okay. So I'll just say print this is a sample code. Okay, I've written a sample code here, sample print statement, and I'll write a print statement after sleep. I'll just say this is the delay. Okay, so what happens is now I'll be giving a time delay of 5 seconds. So what happens is first this is sample code will be printed and you're giving a 5 seconds time delay. So exactly after 5 seconds, this will be executed. So when you want to give some delay to your program, you can use this particular sleep function. Okay, so let's see now. Yes, you can see exactly after 5 seconds, my this particular code got printed. Let me give 10 seconds. So exactly after 10 seconds, my next part of the code will be printed. So in that way, if you want to, this will be helping us a lot when you want to provide some delay to your execution, or if you want to run a code after some time. In that way, if you want to do, this will be helping us a lot, because in many cases we want to provide some kind of delay and all those things. Next, so we have discussed about local time and we discussed about sleep. Next, we have a function called as time itself, time.time. Okay. So basically time.time will return your time in seconds. You can see this is your time in seconds in kind of milliseconds. Okay. Now, what is the use of this particular function? Let me show you. I use this function a lot. I'll tell you where exactly I use. I use this particular function to know how much time a particular code is taking to execute in Python. Okay. How much time a particular code is taking to execute in Python. So let me take a small example. Let's assume that you are for example, I'm just writing a for loop. So I'll just say for I in range. So I'm writing a simple for loop, range of 1000. Okay. And I'll just declare a variable in this. A is equal to some test. Okay. That's it. I'm not doing anything in this for loop. I'm declaring variables. I just wanted to know how much time my for loop is taking for 100 iterations. Okay. So what I can do is, before for loop, I just want to identify how much time is this code is taking. We have a number of ways to identify, but I'm just showing through time library. So what I will do is, I will start my time before for loop. I will start my time before for loop. So I'll just say st is equal to time.time. So I'm starting my time. St is time.time. And I will end my time after for loop. Okay. So I'm taking the starting time of for loop and ending time of for loop. Means before for loop I'm taking st, and after for loop I'm taking et. So time.time will return the current time in seconds. Now if I want to see the total time taken by the for loop, obviously if I do end time minus start time, obviously I'll be getting the current time, total time, right? So I'll just say print total time, right? Total time is what? Your end time minus start time. So if I do end time minus start time, I'll be getting the total time. So right now this for loop is taking less than very low value, means almost 0 seconds. But let me try to increase the number of range. Means here I've taken only 100 iterations, but let me take 1000 iterations. So for 1000 iterations, it is taking slightly a bit of amount of time. You can see 0.001 second. It is in seconds actually. Okay. So I can also write it here in seconds. Cool. Next, let me go for 10,000 iterations. Let's see what happens. Yeah, you can see. Maybe I'll just increase this number. I'm just going on increasing this number. So you can see here, when I'm going on increasing this number, you can see your time increases. Obviously, this time increases, and it took 1.3 seconds for this many iterations. Okay. And moreover, guys, in this for loop, I'm not doing any operation. I'm just declaring a variable. That is the reason it is this fast. But if I start doing some operations, maybe your time increases. Okay. Next, guys, let's assume that I don't want to declare variable also in this for loop. I don't want to do anything. I just want to make my for loop blank. That is not generally possible. If you cannot make anything blank, you cannot make any blank block of code blank. You cannot make any if condition or a for loop or any kind of block of code blank. You should put something in that. So instead of making it blank, there is a keyword called as pass. So I'm explaining about a keyword right now that is called as pass. So if you use a pass, it means that it is nothing but a blank code. Okay, if you use pass, it means that it will just do nothing. It is just iterate and leave it. That's it. It doesn't do nothing. So you can see your time got reduced, because here I'm not even declaring a variable. I'm just skipping it. Okay, I'm not doing anything. So pass keyword will be helping us to maintain an empty block of code. Okay, for example, if you want to make a empty block of code, you can use pass. Okay, pass indicates a empty block of code. It does nothing. Empty block of code. Okay, I would say that empty block of code is pass. So in that way, we discussed about time library, various functions, majorly 3 functions in time library. I'll also show you one more library called as math. So you can simply say import math. And in this particular math, you have all the mathematical operations. See, already in the last class, we have explored about factorial of a number, right? And we have written a code using recursion to identify a factorial of a number. But you can do it very simply here. So you can simply say math.factorial. Okay. And if I give a number here, for example, if I want to find out 5 factorial, I can say math.5 factorial of 5, I'll be getting the factorial of 5. So here you can see, without you writing a code from scratch, see, in the last session we have written code where we were trying to recursively identify the factorial, we were doing the logic, and we were writing the base condition. So instead of doing all those things, if we just call the function of math, you're getting it, right? Or instead of factorial, there are a lot of other functions also, like for example, tan h, ceil, cos h, logs, all those things. For example, if I want to find out log base 2 of a number, so I can simply say log base 2 of, maybe I want to find out of 3. So I'll be getting 1.5. So log base 2 of 3 is 5, something like that. So easily you can do all your stuff using this particular libraries, functions, and all those things. Okay, perfect. Now, next important thing, guys, is okay, you are importing a library in this way and using the library. That's a good thing. But let's assume that your library is something like this. In future, guys, we will be using a library called as sklearn. Sklearn stands for scikit-learn. Let's import that and show you. So I'll just say import sklearn. In sklearn, we'll be using a package called as pre-processing. Let us assume. So I'll just say pre-processing. Okay. So I'm importing this. I'm just saying import sklearn, not pre-processing. Okay. It's a simple library. Next. Now, when I want to use this library's functions, okay, or functions or classes, I should always do like this, right? sklearn.preprocessing dot binarizer, maybe binarizer. I should do binarizer, or sklearn.preprocessing dot label encoder, right? Or if I say I should use sklearn.preprocessing dot label binarizer. So here you can see that always when I want to use a function, don't worry what are these functions all about. These functions we'll be learning about that once we start our machine learning models and once we discuss about pre-processing. But just understand here the concept of libraries here. If you just carefully observe here, when I import a library like this, I should compulsory import the library or use the function by calling the library name, right? So I should always use sklearn or pre-processing. So it will be difficult for me to use that huge name always, right? So just imagine if you're having a library of huge name, it will be difficult to always call the function using that particular library name. So to avoid this problem of huge library name, like calling sklearn pre-processing always, we can do this in a simple technique. That is nothing but alias name. So what you can do is, instead of importing a library like this, you can also import a library like this. Import library name as alias name. So what you're doing here is, to a library name, you are giving an alias name, and alias name is your wish. You can give any small name as alias name. So import library name as alias name. You can give any random name as alias name. Maybe you can give S, A, S, P, A, B, C, something like that. So alias name should not be a keyword. That's it. If it is a not keyword, you can use any name. So what happens is, the properties of all this library will be given to this variable. So alias name is nothing but a variable, guys. It's a variable which is taking all your properties of your library. So as stands for alias. Okay. So in this way, you can avoid the problem of big library names. So let's see how to use that. So for example, let us take time itself. So what you can do is you can simply say import time as t. So instead of using time dot always, you can use simple word called as t. So you can say t dot local time, maybe. You're getting this, or t dot time function, you're getting this, or t dot sleep of 5 seconds. So it will wait for 5 seconds to run. So in that way, you can use t itself instead of this one. In the same way, for sklearn or pre-processing, instead of using this huge name, you can use something called as sp, maybe sklearn for pre-processing. So you can say sp dot so and so function, maybe binarizer, something like that. So instead of writing a huge name, you can use a small name to work with. This is another way of using a library, importing a library and using a library using alias name. But let's assume that I'm so lazy that I don't want to use my use the alias name also. Means what? For example, if I directly say local time, when I import time, and if I say directly say local time, I should get it. But right now I'm not getting it. I should always use a reference, either alias name or time, library name. Or if I say directly say time or sleep of 5, I should get it. But I'm getting a error here. So the thing is right now, if you want to use your functions without using any reference, then you can also import your library in this way. How do you import? Means using slightly in this way. You can simply say from library name import star. Okay, from library name import star. So what you're doing here is from this library name you're importing star. Star means everything, guys. Your star indicates that everything, all modules, all functions and modules. So I would call it as everything. Okay, so from this particular library name, you're importing everything. So when you import in this way, there is no need of using any reference, or there is no need of using any alias name for that. You can directly call a functions directly. Okay, so example is, for example, you can say like this, from time import star. That's it. So let me show you how to use that. So you can say like this, from time import star. Okay, so if I do in this way, if I import my library in this way, I can directly call local time like this. Sorry, local time. You can see previously I was getting an error, but if I import like this, you can see I'm getting my local time. Or if I call sleep function, for example, if I say, let me take the previous code only. And if I use it here, means here you can see here without calling time dot sleep, I can just directly call sleep and I'm getting a delay of 10 seconds, right? I'm getting a delay of 10 seconds. So in this way, I no need to worry about, and if I call time, obviously I'm getting the time in milliseconds. So you can see here, I no need to worry about using a reference name or alias name. I can directly call my library like this. In the same way, for example, if you import math, so I can simply say from math import star. You're importing all the functions. So directly I can say factorial of 5. I'm getting it simply. No need of using math.factorial or m.factorial like that. Okay. So in this way, you can use this way of importing a library, and you can import everything, and you no need to worry about giving alias name or something like that. But in this way, what happens is slightly there is a memory consumption, and there is a memory leakage, because when you're importing all the functions or all the classes, automatically lots of memory will be occupied. So if you have a requirement where you want to use only specific function, for example, let us assume that um, in time I want to use a function called as only a sleep. Okay, or I want to use only local time, that's it. Or in math I want to use factorial, I don't want to import everything. Then how do we import? So what you can do is, you can do like this. You can simply say from library name import function name. Okay, so here you are not importing everything. Here previously when I say star, you are importing everything, but I don't need everything right now. I need only specific function or a specific class. Okay, so you can simply say function name or class name. Okay, so from library name import so and so function. Okay, so let me show that. I'll do one thing. I will do this in a new code because already I've imported here. So I'll take a new notebook and show you how to import only function, only specific function, right? So it's loading. Yeah. So here what I can do is, you can simply say import. Okay, sorry, from time import. Okay, from time import. I want to use, let us assume, only local time. So I can simply say local time. That's it. From time import. So here you are not importing everything. Due to that, you are importing local time and using local time. That's it. So here the memory consumption will be reduced. So you can see I'm using only local time. So if I call right now sleep, it will not work because I've imported only local time. So if I call sleep, or if I say sleep of 5 also, I'll not be getting. It says sleep is not defined because you have not imported sleep. You are imported only local time. Okay. Or for example, if I say from math import factorial. For example, if I want to identify the factorial of a number, so factorial of 5, that's it, I'll be getting 120. What if I say log base 2 of 5? I will not get this because it is not defined. Okay, now let's assume that here I'm importing only one single function, right? One single function or one single class. But if I want to import multiple functions, okay, not single function, but I want to use multiple functions, then what I can do is, I can do like this. From library name import function name or class name, comma, you can give a comma and give multiple functions. Means you can give like this. Right now we are not working with classes, guys. In future we'll be working. So I'm just link the reference to you. Like you might have classes also in future for working with. Okay, function name to class name to. If you want to import the third one, so you can go on importing that many number of functions or classes for your use cases. Okay, so in this way you can import a specific function or classes, multiple functions or classes. So let's see here itself. For example, here I want to use local time and sleep, both I want to use. So what you can do, you can simply say from time import local time comma sleep. So your local time will be imported and also sleep will be imported. So obviously I can use local time, I'll be getting that. Okay, local time, spelling mistake. Okay, and obviously I can use sleep also. So let me take this code only, sleep. Obviously I can use sleep also, it works because we have imported both. In the same way here, I want to use like factorial and log base 2. I can simply say factorial comma log base 2 and both will be imported for me. So you can see now previously log base didn't work, but here now it came. So in this way you can import multiple libraries, multiple things in this way, right? So these are the major ways of importing a library. So I guess we have discussed all the major ways of importing a library. So you can simply see this. These are the different ways we can import a library, right? So depending upon our requirement and depending upon our use case, you can import in this ways. Cool. Cool. So now we have understood about how to use a library, how to call a function in a library. Now let's talk about non-inbuilt libraries or non-built-in libraries. Okay. So till now we were mainly focusing on built-in libraries like time or math were inbuilt libraries. Of course, scikit-learn was not built-in, but when you install Anaconda platform, as you have installed Anaconda platform, as I told you already, Anaconda platform has lots of data science packages pre-installed. So sklearn is one of the data science packages, which is a very famous data science package. So it is already installed. Okay, even though it is not built in, when you install Anaconda platform, it is installed. So that is the reason, even though I have not installed, I am getting it. But there will be some libraries which you have to install explicitly, which are not inbuilt. What are those? For example, let's assume that in future we will be using a library called as MLExtend. MLExtend, it's like a machine learning extension. Then how do we import that? For example, if I say like this, import MLExtend. Okay, I'll just say import MLExtend. So I would say that if this particular library is not installed, I would get an error called as module not found error, no module MLExtend. I would get this error. Why I'm getting this particular error? Because basically what happens is whenever you're importing a library, guys, your Python will go to a folder called as site packages folder. Okay, in your Anaconda folder, there will be a folder called as site packages. In that particular site packages, all your libraries will be present. If this particular library called as MLExtend is not present in that particular folder, it means that you have not installed your library and you are getting this error called as module not found error. Now, how do I handle this? So if you want to handle this, or if you want to use this library, you have to install this library. Then how do we install this library? So to install a library, you should use something called as pip tool. Okay, there is a predefined tool called as pip tool. You can use this particular pip tool. Pip stands for Python install package. So you can use this particular pip tool to install a library. But the thing is, where exactly the libraries are present? So where exactly the libraries are present means it is present in a repository called as PyPy, pypy.org. So you can just go to this particular repository that is called as pypy.org. So if I just go to this particular link, you can see all the open source libraries developed by a number of developers. Okay. So if I just say pypy.org, you can see so many developers has developed so many libraries and they have published in this particular repository that is called as pypy.org. So approximately you can see we have 3,49,831 projects right now, means libraries right now, which are related to multiple things. And if you just scroll down, you can see lots of trending projects. These are right now trending projects and new releases right now. So in this way, you can actually publish a library I mean, in this particular repository only you can publish a library and you can download from. Now here we are mainly focused on ML extent, right? So you can just search for ML extent. Okay. So when you search for ML extent, you'll be getting this. You can see this is the ML extent and this current version is working on. Now, how do you install this? How do you install means it's very simple. You can use pip tool as usual, I told you. And pip tool, you'll be getting it when you install Python. So you don't have to worry about again downloading pip tool or again worrying about pip tool. Automatically, you'll be getting that tool once you download Python or Anaconda. So how do we install means it's very simple. You should go to terminal or command prompt and you should run this command pip install so and so library name. Whatever library name you want to use, that one. Right now, as we want to use ML extend, you can simply say pip install ML extend. Pip install ML extend. As simple as that. So let me show you how to install this. So either you can go to Anaconda prompt. Either you can go to Anaconda prompt. So if you just search for Anaconda, you'll be getting this Anaconda prompt, or you can go to command prompt. Either way. So sometimes you might not get installed in command prompt because of the maybe you have not added Python in the environment variables. In that case, you have to use Anaconda prompt. Either way, both works. Okay. So I'm just installing in command prompt either way. So whenever you're opening a command prompt, guys, don't open directly because there is a chances of getting some permission errors in some cases. So to avoid all these permission errors, I would recommend open command prompt in administrator mode. So I'm just running as administrator. It is asking me for permission. I will give that. And now I can run this command called as pip install ML extend. Okay. So once I run this command, what happens is, and remember guys, whenever you're running this command or whenever you're installing, you should compulsory have internet connection, active internet connection, because what happens is whenever you run this command, it will actually go to the internet. I mean, it will go to the PyPy repository. It will search for the ML extend from the cloud, download that particular code and put it in your site packages. So all this process happens in the backend. So that is the reason you should have an active interconnection. So you can see there are a few dependencies of this particular libraries also. Those are getting checked. And you can see it is saying installing Calculate packages ML extent. It has downloaded. Now it is installing the package. So it says successfully installed ML extent. And you can see the version here. The version which you are using is 0.19.0, means it has installed the latest version of the library. Okay. So successfully we have installed the ML extent. You'll be getting one warning, that is to upgrade your pip. No need to worry about that. If you get this warning, no need to worry about that. But yeah, we have successfully installed the ML extent. Now let's go back and see whether we are able to import ML extent or not. So I'll just go back to my code and just say import ML extent. Yes. Now we were able to import ML extent because you have installed it right now. Means your ML extent code is present in the site packages, and you can see here. If you want to see the folder here, you can see it is storing all your libraries in this particular folder, that is C program data Anaconda lib site packages. In this particular folder, all your libraries are present. Okay. So now let's start using this library. Means of course we don't use right now depth, but let's start with identifying the version of the library. So if you want to identify the version of any library, guys, it's very simple. ML extend dot or library name dot underscore double underscore version double underscore. So if I say like this, I can see the version of a library. Right now you can see I'm working with the 0.19.0 version. Okay. ML extend dot underscore. It's double underscore version double underscore. So in this way we can see the version. Okay, very good. Now what are versions? Now let's talk about versions. It's very important. See guys, let's assume that you as a person who has developed a library right now, as a developer, you have developed a library right now and released into the market. A lot of people are using, let's assume you have developed a library for mathematics, for mathematical modules or calculation modules. A lot of people are using your libraries, and few developers need your some extra features in your library, or few developers requested for some modifications in the library or some bug fixes in the library. Then what do? You do that fixes, or you add some extra features and you release as a new version. So older version will be as it is, and you'll be releasing this one as a new version. Like in general, if you take applications also, for example, if you take a WhatsApp, so in regular basis you'll be getting some updates. So what happens when you get a app update? It may be WhatsApp or Facebook. What happens? All the bugs whatever we have in the previous version, that will be fixed. and also there might be some extra features. In the same way for libraries also, if there is any bugs in the previous versions of the library, that will be fixed in the latest versions, and also few kinds of what we call few kinds of maybe extra features will be added in this particular in the latest version. So in that case, when you're working in a company, guys, there is very important thing is you have to maintain your versions. Let's assume that today you have developed a software in your in your company, okay, and you have developed a software using some version, some X version, and you have deployed into the cloud. In deploying your cloud, you have not maintained the version. Maybe here you are using something like 10 version. In cloud, let us assume 11th version was installed. There is a high chances that the output what you got or the results what you got in your local system might not match with your cloud system. There will be huge problem of disparity. Then obviously that's not a good way, right? We should always maintain the same versions, and you should also maintain the same outputs. Means whatever output you are getting in your system should match with the deployment environment, right? So in that case, you should use again that particular version. You should install only that particular version of library. Means your environment, whatever you are using, whatever you are developing, should match with the environment made in the cloud. So in that way, if you want to install a specific version of a library, see, when you say pip install library name, it will install the latest version. But I want to install a specific version of library. So if you want to install specific version of library, it's very simple. You can simply say pip install library name equal to version. Okay, equal to version. So if I say like this, it will install only that specific version of a library. It will not install the latest version. So let us try this. Okay. For example, now let us assume that if you just go back, but if you want to see what are the versions available in this particular any library, you can just go to PyPy repository, and here you have a tab called as release history. So if I just go to release history here, you can see all the various other versions of the library here, previous versions of the library. Right now we are in 0.19.0, which was released on September 3rd, 2021. But you can see there was a previous version. You can see the complete release history. Let's assume that I want to use 0.18.10 because let's assume that there was a feature in 0.18.0 that right now let us assume that that particular feature is not present in 19.0. So I want to use that feature. Then I have to go back to my previous version, right? So how do I go back? It's very simple. So you can simply say pip install 0.18.0 double equal to 0.18.0. So let me run this command in command prompt and see what happens. So I'll go back to my terminal and run this command. So when you run this command, what happens is if there is an existing library already present, it will uninstall first. It will, because already we have 0.19.0, right? It will uninstall that particular 0.19.0 and install this version. So let's see how it happens. Let me run this command and let's see how exactly this works. Okay. So version maintenance is very important, guys. So in this way, if you provide your version, that will be avoiding the disparity issues, and you'll be getting same kind of results. And sometimes some features also might not be present in the latest versions. So in that case, maintaining the same version is very important when you're using specific features. So you can see here right now, it says that it has already found one existing installation, that is MLXN 0.19.0. So first it is uninstalling the existing version, and it is first after uninstalling the existing version, it will install the latest version. So you can see it has successfully installed the latest MLXN version, that is 0.18.0, and the previous version got uninstalled. Okay. Now let's go back and see. Right now, guys, if I run this code, again import and again this, I'll be getting the same thing because already it is imported. So to check whether it is working or not, I should first restart my kernel, because what is kernel restart basically? What happens when you do kernel restart? So if you go to kernel and if you click on restart. So what happens when you do a kernel restart is all your variables, whatever was imported, or sorry, whatever was created, or whatever libraries was imported, all these variables will be created. Means you start your interpreter from first. So all your temporary memory and everything will be removed. Okay, like that. So if you want to start your execution from fresh, you can use a restart kernel. So I'm restarting here. Done. So my kernel is restarted. Now I'll try to import and see what happens. Okay, my MLXN got imported right now. Now let me check the version. Yes, we have successfully downgraded our version to 0.18.0 from 0.19.0 because we found that there was some feature we needed. Okay, so in that way we can install specific version of a library in this way. Cool. Now let's assume that okay, you have 0.18.0. Maybe let's assume that I want to upgrade to the latest version again. Okay, if you want to upgrade to the latest version, for example, if I say again pip install ml extent only, pip install only ml extent, it will not upgrade. It will just stay there. Means it says requirement already satisfied. Means already the library is present. So you are not there is no installation happening here. If I just only say pip install ml extent or pip install library name, it says you can say requirement already satisfied ml extent. You can see it says that already ml extent is present in this package 0.18.0. So it will not do anything. It does nothing. So if I run this command and go back and restart my kernel, okay, and if I import ml extend also, still I will be in the old version only. Even if I import here, you can say I'm still in the old version only. But if I want to upgrade it, I should slightly do a different way. What I should do is I should say pip install library name space hyphen upgrade. So if I use this command, if you are present in the lower version of a library, means this command should be running. You should run this command only when already you have a library. If you don't have a library, you can just simply say pip install so and so library name. It will automatically install the latest version. But if you already have a library, but it's a lower version, and if you want to upgrade it, you should run this command. Okay. So let me run this command right now. So I'll just say pip install ml extend hyphen upgrade. So if I say pip install ml extend hyphen upgrade, it will upgrade to the latest version of my library. So let's see. So the upgrade is going on. Let's see what happens. So in this way, you can upgrade to a specific version of a library. Yeah, let's see. So you can see it is finding for ml extend 0.19.0 here. Let's check what happens. Yeah, you can see it is actually uninstalling the previous version of library, that is 0.18.0, because it has found that, and it has successfully uninstalled. Now it has successfully installed the 0.19.0 version. Okay. Now let's go back and check. I'll do the restart kernel again and check whether we were able to successfully upgrade to the latest version or not. Let's see. Yes, we have successfully upgraded to the latest version. So in this way, you can upgrade to the latest version, or you can install specific version, or you can install library in this way simply, right? Now let's assume that you want to uninstall a library. Let's assume that you're not using that particular library, you're not using it, and it is unnecessary wastage of memory, right? So you want to uninstall it. So if you want to uninstall a library, it's very simple. You can simply say pip uninstall library name, as simple as that. Okay, so whatever library is present in your, whatever version it might be, whatever library is present in your system, that will be uninstalled. Okay, so let me uninstall a library name. Okay, pip install ml extend, pip uninstall ml extend. So I will run this code right now. So it is right now uninstalling my ml extend. So let's see what happens here. So first it is just finding out whether we have ml extend or not. If it is yes, so it is asking yes, it has ml extend, and it is saying that. So you can see here, whenever you are uninstalling, it is saying that it would remove the ml extend from this particular folder. Means it will remove the site packages folder. From the site packages folder, it will remove ml extend. It is asking for the permission, yes or no, for confirmation. If I just press yeah, Y and enter, yes, it has installed, because it is asking for confirmation. If I just Y stands for yes and N stands for no. If I say Y and click on enter, it will successfully uninstall ml extend. Now if I just go back, restart my kernel, right? And if I see, first thing, if I just import, obviously I should get an error here because I have installed it. Yes, I got an error because I have uninstalled my ml extend. So in this way, you can work with an external library. In this way, you can work with an external libraries in this particular way. Okay, perfect. Now in industry, guys, when you're working in a company, let's assume that you have developed a module or your colleague has developed a software and you want to use that particular software. And your colleague has used some n number of libraries of specific versions. Now you want to maintain the same environment or same kind of libraries if you want to use in your system also. Then how do you do that? So in industry, guys, there is something called as requirements.txt. So what is this requirement.txt means? It's a file, it's a text file which has all the libraries along with the versions. So you always, whenever you want to install more number of n number of libraries of specific versions, I would recommend to use requirement.txt. So let me show you first how exactly this requirement.txt files look, and then I'll show you how to install libraries from requirement.txt. Okay. First, I'll open a simple notepad and I'll create a simple requirement.txt. Okay. So here, how the requirement.txt look means, first we should start with like putting the library names. So I'll just say NumPy. Maybe I want to use a library name called as NumPy, and I want to use maybe 1.16.0 version of NumPy. So I should give the NumPy library name and the version. Done. Next, let's assume that I want to use ML extend. So I'll just say ML extend, and the version is 1.18.0. Maybe I want to use pandas. Okay, so let me check the version of pandas online in the PyPy repository. What are the versions present? So we just say pandas, and this is not the original one. Yeah, so you can see the latest version is 1.3.5. Maybe let us assume that I want to use 1.2.0. So I should say pandas equal to 1. So here you can see here I am writing a text file where I am including the multiple libraries along with the versions like this. Okay. So in a single go, I can install all these libraries, but I should first save this in a form of text file. So let me save this. I'll do one thing. I'll just save this file in our what we call existing code itself, that is data science folder. So this is our requirement.txt look, guys. This is a very famous text file you always get when you're using Python, when you're working for a specific module. Now let me show you how to install your libraries by using this requirement.txt. The command for installing a library using requirement.txt is very simple. You can simply say pip install -r. -r indicates that you're installing from a text requirement.txt file text file. So -r requirement.txt, as simple as that. Okay. So in this way, I have defined the libraries along with the versions. So I'll just close this requirement.txt right now. Now what I should do is I should go to my command prompt and give my command to install. So what is the command? It is very simple. It is pip install -r. -r stands for requirements. So requirement.txt. So if you run this command, it will install from the requirement.txt file. So let me run this command right now. So to run this command, first I should go to the requirement.txt file where I have my where exactly the folder is present. So right now it is present in the data science folder. So I'll just go to my data science folder and just run this command pip install -r requirement.txt. So if I run this command, all the libraries which is present in that particular requirement.txt along with the versions will be installed. So in a single go, if you want to install multiple libraries along with respective versions, you can use this requirement.txt method. Okay. So you can see it is installing. So you can see it's downloading NumPy 1.16.5 version, pandas 1.2.1 version, ML extend 0.18.0 version. So I guess now it should be satisfied. Yes. So it is already having some NumPy version. So yes, it is installed. But sometimes you might get this particular environment error because I have not opened my command prompt in administrator mode. It's very simple, not a worry. So to avoid this error, you can also use a simple technique called as -user here. So in this way, if I use -user here, it means that you are giving a user permission to install the libraries. So if you get any error called as environment error or access denied, it's like nothing but your permission error. So in that case, if you append -user here, this particular environment error will be resolved, and it will install all your libraries, whatever we have in a requirement.txt in a single go. So in this way, you can use a requirement.txt file. So let's see once it is installed. Yes, it is already having one installation. It is uninstalling first. NumPy we already have 1.18.0. It will first uninstall the 1.18.0 and install 1.16.5 because we have mentioned the same in the requirement.txt, right? So let's wait. Yeah, so you can see, so right now it is successfully installed all the NumPy pandas versions of specific versions. By chance, if we get any same error, something like access denied or something like that, you can reinstall that by opening your command prompt or Anaconda prompt in administration mode. That should solve the issue. But if you get like this successfully installed, that's not a problem. I got this error because there was some kind of dependency error. I don't need to worry about that for now. But this is how you should install requirement.txt in this way. Next. So our next concept is working with virtual environments. Virtual environments. So what exactly is virtual environment? So let's assume that if you want to maintain a library of a specific version in your system and the same library of other version in your system only, then you have to use something called as virtual environment. So why do we need that? Okay, let's assume that you are working with multiple projects. Okay, you are working with multiple projects. Let's assume project 1 and project 2. Okay, you are working with multiple projects, project 1 and project 2. Now, let's assume that project 1 need NumPy version of 1 point maybe 16.5. Maybe project 2 need NumPy version of 1.18.0. Right? So in this case, when you have multiple projects and if you want to work with multiple projects with different versions of the same library, then you have to maintain something called as virtual environments. So virtual environment is like an environment where you can install specific libraries and those particular libraries will be installed only in that particular environment. It's like a folder where you'll be having all your libraries present, not in the site packages folder, but it's a folder separately created for you. And in that particular virtual environment, you'll be having all your libraries. And whenever you run your Python codes from the particular environment, only that particular libraries will be used. So when you install your libraries in that particular environment, your main environment will be not affected because right now whatever we are working on, it's a main environment. Here itself, you're installing all the libraries, right? So when you install, for example, now if I say NumPy install 1.16.5, it will install 1.16.5. For example, if I say NumPy install 1.18.0, it will uninstall 1.16.5 and it will install 1.18.0. So you cannot maintain two versions in a main environment. So that to maintain that, we should use virtual environments. So virtual environments will be helping us when you want to work with multiple projects with the same libraries. Okay. So let us assume project 1 is bank. For example, you are working with a bank project and project 2 is maybe something like a retail project. Okay. Retail project. So in this case, when you're working with bank or some other project, you should use virtual environments. So how to use that? Okay. So let's see how to create a virtual environment. So if you want to create a virtual environment in Anaconda, should use a command called as conda create. This particular command will be helping us to create a virtual environment. So conda create -n environment name. And Python, even you can maintain different versions of Python because maybe project 1 might need 3.6 version of Python. Maybe project 2 need 3.7 version of Python. So you can maintain two different versions of Python here. So how to run that? Very simple. So for example, for project 1, like 6, for example, it's a bank environment, bank project. So what you can do, you can simply say conda create -n, maybe bank environment. You can say bank environment. Okay, Python. Maybe I want to go with Python 3.6 in bank environment. Okay. And maybe let's assume that project 2 is retail. So we'll just say RET environment maybe. So retail environment. So when you're working with bank project, you'll be activating this environment. You'll be activating this environment and the versions of this particular library will be in this particular environment and you'll be using that. When you're using retail project, you'll be activating the retail environment and you'll be using that. First, before activating, but let us have to create the environment. So let's see how to create. Let me run this. Maybe let's assume that retail is using Python 3.5. You can do like that. So you can maintain different Python versions, different library versions by using the virtual environments. Okay. So let's see first creating a bank environment. So let's go to this command prompt and run this. and click on enter. So it starts creating my Python environment. It'll take some time. It'll take a lot of time to install all the packages and all those things. So I'll just say click on Y. So it'll ask for the permission. It says already I'm having an environment. So I'm just bank environment. I'm just removing that. Okay. So if you don't have, not a problem. It doesn't. So it starts creating a virtual environment. Once it's created, if you want to use the virtual environment, you should use command called as conda activate environment name. My environment name is what? Bank environment. So environment name. Okay. So in our case, conda activate bank environment, because I want to use for bank environment. So what happens is when you say bank environment, only that bank environment libraries will be used. So that will be a good thing for you. Okay. Okay. Bank environment. Cool. So let's see. So you can see it is actually creating environment. It will take some time. So let's wait. So you can see right now my environment is created. So in between it will ask for the permission to proceed. So you can just say Y and it can proceed, and it will install the basic libraries and install. So you can see right now my environment is created, but you have, in order to use the environment, you have to activate the environment. If you want to activate the environment, you can simply say conda activate bank environment. So let me take this command and if users. So now once you say conda activate bank environment, it will activate the bank environment. So you can see right now we are in the bank environment, and whatever libraries you installed. For example, now if you say pip list here, there's a command called as pip list to see what are the libraries present in your environment. So you can simply say pip list. That will list you all the libraries present in the environment. So you can simply say pip list. So if I say pip list here, it will list out all the libraries present in the bank environment right now. So the moment you create a bank environment, you'll be getting some predefined. You can see only few libraries are present here. Okay, very few. So there is no NumPy, there is no pandas, nothing. So if you install, if you have to install from scratch everything. So if I say pip install NumPy 1.16.5, only that particular NumPy will be installed in your bank. So this will be installed in the bank environment, not in the main environment. Main environment will be as it is. So you can see it is downloading the 1.16.15 version, and it is installing the colored packages in my bank environment. So like this, I can maintain different environments like this. Yes. And yeah, so you can see I can maintain like this, and I can use like this. Okay, so if I say now Python here, now right now it is in the 3.6 version, because I told, right, I have created my bank environment in 3.6 version. So I can say, if I say Python, I mean 3.6 version. So if I say like this, import NumPy, and if I say NumPy dot underscore version underscore, you can see I'm in 1.16.5 version. So in this way, in this particular environment, I'm having like this. Whereas if I say import pandas, I would get module not found, because in my bank environment I don't have pandas, whereas in main environment I was having pandas, but in the bank environment I'm not having pandas. So I have to install again pandas explicitly. So like this, you can maintain multiple environments in your system, virtual environments in the system, and for your respective project. And if you want to deactivate environment, it's very simple. You can simply say conda deactivate. Okay, so it will deactivate the current environment, and it will come to the main environment. Now if I just go to Python here, yes, you can see right now we are in the Python 3.7 version. See, in bank environment we were in Python 3.6 version, but in the main environment we are in Python 3.7 version. So like this, you can maintain different Python versions, different library versions by using virtual environment. So you can take a task and create a one more environment called as little environment in your system with Python 3.5 and experiment with that. Okay, this is how you'll be working with libraries, external libraries, and virtual environment, guys. Okay, thank you.